Okay, so let's talk about this, the use of azimuths and bearings, and now we're going to start talking a little more about direction. So, and you're going to totally hear me slaughter this word, and that's because it's hard. It's hard for me to say, but anyway. What's an azimuth? It's the clockwise angle from the north or south end of the reference meridian to the line in question. So generally it's measured from the north end of the meridian. Some people use the south, but depending, it'll be clear how it's being used. So the magnitude can be 0 to 360. And each line has two azimuths if you think about a forward and back. And it can be astronomic, magnetic, or assumed. So your north can be astronomic, magnetic, or assumed. That's what I meant. So if you think about, okay, so line AB has an azimuth of, it's 60 degrees north, right? Whereas the A to C is 172 degrees, and A to D is 284. Now, what do I mean by back and forth? Well, what that means is that if AD is 284, then D to A would be backwards, would be like your back angle, and that would be equal to, let's see, however long it takes for me to get to 360. So 360 minus 284. I should be able to do that in my head, right? But I'm too lazy. So AC 360 minus 284, so that's 76, right? Okay. So anyway, we're going to talk about these, but it's important that we also distinguish azimuths from bearings. So there's people that use one more than the other. I believe azimuths are used more often, but actually, I'm not sure. I guess it depends on the application and the person and the company. But what bearings are, they're similar, but what it is it describes the smallest angle which that line makes with reference to another meridian. So we're going to talk about quadrants. Your northeast, northwest, southeast, southwest. So if you have, this is north, south, east, and west. This is my northeast quadrant, my southeast quadrant, my southwest quadrant, and my northwest quadrant. So that's how that works. And so if I have an angle here, it's in the northeast quadrant, and there's a very specific way to write about it. So let's say that that this is exactly the line that I just drew. So this is the way you write it is north 60 degrees east. So what this is saying is this is 60 degrees from north toward the east. Now every line has two bearings. So if this is north 60 degrees east, it can also be south 60 degrees west, because the way that happens is what happens if I extend that line, then from south towards west, this also needs to be 60 degrees, right? Just math. So if I do that, that's fine. Both of these are true bearings of that same line, depending on where you put your reference point. Okay, cool. We're going to work with these to figure out, to do some traverse calculations. But before we do, let's talk about our compass. Now, your book kind of goes into a lot of detail about what's good and bad about your compass. I'm just going to give it to you straight. Well, before we do, let me tell you this. So, Earth Direction Finder is a magic magnetic and amazing poles. So, compass has been used for centuries to measure angles and find direction. So what the way it works is the compass needle lines up with magnetic north, which is not necessarily true north, because depending on where you are, there is a little bit of a difference, also depending on time. So magnetic poles are not points, they're oval areas, and the complication is that they move and they change, and depending on where they are, they're pulled a little off by a few minutes and seconds here and there. So it's the precision obtained when you use magnetic meridians or the magnetic north is limited. So compasses are becoming more and more obsolete, and we're using more other methods such as GPSs and whatnot. But they're useful for certain things, especially if you're using them just as more like an assumed or like a beginning reference point. But yeah, in general, people are kind of moving away from compasses just because they change depending on time and place and location and whatnot. So there's something called magnetic declination. So magnetic declination is the angle between astronomic north, which is also called true north, and magnetic north. So how do you measure this? Well, pretty much there's people who have fancy devices who put this stuff online. So you go online and you type in magnetic declination calculator, and it'll, depending on where you are located, you see latitude, longitude. There's a couple of different models, and then the date for which, now if you're doing it today, it can be today, or you could be looking up, like let's say that you found a survey that says certain things, but you notice that they were using a compass, or they were using magnetic meridians, and therefore you can check, the survey for my house was made in 1983, so let me see what it was back then. Or you can just use this, like, well, first you can look up your latitude, longitude. So long story short, this can tell you where you are at. And we're going to talk about how to calculate that and how that makes what impact that has over in the next video.